Assalamu alaikum wa rahmatullah. Dear students, today we will discuss the last topic as far as the polymer chemistry is considered. The title of the topic is Biodegradable Synthetic Polymers. It's the last topic of polymer chemistry. As far as this very topic is considered, first I will give you the idea of biopolymers. Biopolymers. Then we will discuss this very topic. Biopolymers are the polymers present in the biological system. For example, if you have polysaccharides includes starch, we have the cellulose, or you can have the proteins. The polymers, proteins, these are the polymers of amino acids. We have discussed these polysaccharides, proteins, nucleic acids in the biomolecules. Proteins, these are the polymers of amino acids. Remember this point. It is the biopolymer. Proteins are also biopolymers because these are the polymers present in the biological system. Or you can have nucleic acids, DNA, RNA. We have to discuss these three: polysaccharides, proteins, nucleic acids. Remember this point. Or you can have the lipids. Remember this point. These polymers, polysaccharides, proteins, nucleic acids, they are present in the living system, and these are known as biopolymers. These biopolymers have a special property. And what is that special property? They degrade in the biological system. They degrade in the biological system after certain fixed period of time. Remember this point. This is the specialty of biopolymers. First, you should remember these are the polymers which are present in the biological system. It includes polysaccharides, it includes proteins, it includes nucleic acids, DNA, RNA. And these biopolysaccharides, proteins, nucleic acids, they have the special property. And what is that special property? They degrade in the biological system after certain fixed period of time. Hence, these biopolymers are biodegradable in nature. Remember this point. Biodegradable in nature. What is meant by biodegradable? They degrade in the biological system after certain fixed period of time. This is the base of this very topic. Why we try to synthesize synthetic polymers which are biodegradable. If you have the polythene, that is synthetic polymer. If you have PVC, polyvinyl chloride, that is synthetic polymer. But they have the problem, they are non-biodegradable. Polythene is non-biodegradable, PVC non-biodegradable. We want to synthesize, we want to prepare those synthetic polymers which are biodegradable in the biological system, which are biodegradable in the environment. If we talk about the polythene, just understand the topic. If you have polythene is a synthetic polymer, but polythene, it is non-biodegradable in the environment. It does not undergo degradation, it is non-biodegradable. But we want to synthesize, we want to prepare those synthetic polymers which are biodegradable in nature, which are biodegradable in the environment, which are biodegradable in the biological system. Remember this point. It means that biopolymers are biodegradable. We want to synthesize synthetic polymers which will be also biodegradable in nature. These biopolymers, when they are biodegradable, they degrade in the biological system after certain fixed period of time. Hence, they do not cause any pollution problem. Remember this point. Why we want to synthesize synthetic polymers which are biodegradable? Because at that time they will also not create any pollution problem. Remember this point. It means that biopolymers, they are biodegradable. They degrade after certain period of time, after weeks period of time, after 1 month, after 2 days, they degrade themselves. Hence, they do not cause any pollution problem. But on the other hand, if you have the synthetic polymers like polythene, it is non-biodegradable. It does not degrade in the environment. Hence, polythene has produced a havoc in the universe. Remember this point, because it is non-biodegradable. It cannot undergo degradation at its own will. It is non-biodegradable in nature. Hence, chemists have tried a lot to synthesize, to prepare synthetic polymers which will be biodegradable like biopolymers. Hence, at that time, synthetic polymers cannot also create any cause of pollution problem. Remember this point. Hence, we have the topic biodegradable synthetic polymers. We try to prepare synthetic polymers which will degrade themselves either in the biological system or in the environment. Remember this point. And we try to prepare synthetic polymers which will be also biodegradable in nature. This is the important point you have to mention. You have to mention the polymers. I will talk about the polysaccharides, proteins, and we have the nucleic acids, the polymers. This is the first point you have to mention. The polymers like polysaccharides. We have to discuss polysaccharides in the biomolecules. Polysaccharides. You have proteins. You have nucleic acids, etc. The polymers like polysaccharides, proteins, nucleic acids, etc., which controls, what is their specialty? Which controls various life activities. These are the polymers, the polysaccharides, proteins, nucleic acid, which controls various life activities, processes. Remember this point. Activities means life processes are called, इन्हीं को हम कहते हैं, are called biopolymers. And what is the specialty of biopolymers? These polymers, I mean to say biopolymers, these polymers are biodegradable in nature. Biodegradable in nature, that is, what is meant by biodegradable? That is, they degrade they degrade after certain intervals of time. This is the first point you have to mention. Why we want to synthesize, prepare synthetic polymers, biodegradable, which are biodegradable in nature, because these biopolymers, they are biodegradable and hence they do not cause any pollution problem. These polymers are biodegradable in nature, they degrade after certain intervals of time, hence they do not cause any pollution problem. Hence, they do not cause any pollution problem. You have to mention. It means the biopolymers, their wastage, their disposable is not a problem for we people, as because they do not cause any pollution problem. Now we will relate this very topic with the synthetic polymers. You know synthetic polymers like polythene, like PVC, they are non-biodegradable in nature. They do not degrade either in the biological system, either in the environment. Hence, they are non-biodegradable and they cause pollution problem. Remember this point. You can mention. On the other hand, synthetic polymers like polythene is a synthetic polymer, man-made polymer. You have PVC, polyvinyl chloride. You have polyacrylonitrile, etc. These are synthetic polymers, are non-biodegradable in nature, non-biodegradable in nature. Non-biodegradable in nature. What is meant by non-biodegradable? They do not degrade in the environment. Hence they cause pollution problem. Now, why we try to prepare synthetic polymers which are biodegradable? Pollution problem. In order to overcome this problem, in order to overcome this pollution problem, we try to synthesize polymers which will be biodegradable in the living system, which will be biodegradable in the environment. At that time, there will be no pollution problem. Remember this point. Hence, this is the topic, biodegradable synthetic polymer. We will prepare synthetic polymers which are biodegradable in nature. Remember this point. In order to overcome this pollution problem, nowadays we prepare polymers which are biodegradable in nature. You have to mention. We try to prepare those polymers which are biodegradable in nature. When they degrade, they will not cause any kind of pollution problem. Now, how we can prepare these biodegradable synthetic polymers? I will mention here, which are biodegradable in nature, by introducing. How we can prepare, this is the point, by introducing the functional groups. By introducing the functional groups which are present in biopolymers. This is the simple point you have to mention. Biopolymers are degradable because of some functional groups, and we try to introduce those functional groups in the synthetic polymers. And because of those functional groups, the synthetic polymers will be degradable in nature. Now they will degrade. You have to mention how we can prepare biodegradable synthetic polymers by introducing the functional groups which are present in biopolymers. Remember this point. You have to simply remember, we want to prepare synthetic polymers which are biodegradable, hence they do not cause any pollution problem. Remember this point. And how we can prepare? This is the point, by introducing the functional groups which are present in biopolymers. Remember this point. Now we'll discuss some biodegradable synthetic polymers, some important biodegradable biodegradable synthetic polymers. Synthetic polymers. Some important biodegradable synthetic polymers. We'll discuss. We have three important examples from our text. Around this point. Right now, the first one, we have the first one, that is polybeta hydroxybutyrate. Polybeta hydroxybutyrate. Polybeta hydroxybutyrate. It means there will be copolymerization. Polybeta hydroxyvaleriate. Valeric acid having 5 carbon atoms. Butyrate means butyric acid having 4 carbon atoms. We have discussed these in the carboxylic acids. pH BV. Polyhydroxybutyrate valerate. On this point, polybeta hydroxybutyrate. This is the first biodegradable synthetic polymer. Polybeta hydroxybutyrate. Butyrate means butyric acid having 4 carbon atoms. Co means copolymerization. Monomers are different. Copolymerization. Beta hydroxyvalerate. Valerate means having 5 carbon atoms, and it is abbreviated as PHBV, polyhydroxybutyrate valerate. Now we will see what is the reaction. First you have to mention it is a thermoplastic. This is the first point you have to mention. It is a thermoplastic. Plastic copolymer. It is a thermoplastic copolymer obtained. You have to mention it is preparation obtained by polymerization of beta hydroxybutyric acid, and beta hydroxy. Butyric means having 4 carbon atoms. Beta hydroxyvaleric acid. Valeric acid. This is the point you have to mention. Now we will see its reaction. You have this one, C double bond OH, carboxylic acid. It is alpha carbon. This one, it is beta carbon. Here we will have OH and we will have methyl. Its name will be alpha beta hydroxycarbon 1, 2, 3, 4 butyric acid. This is beta hydroxybutyric acid. You can also write it as IPAC name, beta hydroxybutyric acid. Its IPAC name will be 1, 2, 3 hydroxybutanoic acid. You can also mention its IPAC name 3 hydroxybutanoic acid. You can also mention its IPAC name. It's enzymes because polymerization. Now you have beta hydroxy. Same, we have C double bond OH. You have alpha carbon. You have beta carbon. Here we have OH. Now we have 1, 2, 3, 4, and 5. Valeric acid. Valeric means it has 5 carbon atoms. It is beta hydroxyvaleric acid. Beta hydroxyvaleric acid. This one is beta hydroxybutyric acid. This one is beta hydroxyvaleric acid. And when you bring it as polymerization, condensation polymerization runs point, this HOH will come out. You will have OH will come out. Here H will come out. Remember this point. H will come out. And you can say H from this OH will come out. H will come out. minus water will be there. We have already discussed minus twice and minus water. This is the way. What you will have now, you will have CH, CH3, CH2, C double bond O, ester linkage is being formed, C double bond O. You will have CH, you will have CH2, CH3, you will have CH2, you will have C double bond O. This is the PHBV. This is polyhydroxybutyrate valerate, PHBV, obtained by the polymerization of beta hydroxybutyric acid and beta hydroxyvaleric. Is the first synthetic biodegradable polymer, PHBV. Come on this point. Now we have the second one. We have second biodegradable synthetic polymer, that is, second is polyglycolic acid. It means that one monomeric unit will be glycolic acid, polylactic acid. Second will be lactic acid. It means that here the two monomeric units are glycolic acid and lactic acid. You can mention commercially, on large scale, commercially it is called dextron. Commercially it is called dextron. It is called dextron. It is the first biodegradable synthetic polymer. Synthetic polymer used in switching wounds after operation. Why we make use of this biodegradable synthetic polymer used in switching wounds after operation. Around this point. What is the quality of this? It degrades after weeks of time in the biological system automatically. It is biodegradable. It degrades after weeks of time in the biological system. You can also mention it degrades after weeks of time, after weeks time in the biological system. You can mention it. It means that it is biodegradable synthetic polymer. Now we will see the reaction, glycolic acid and lactic acid, how they undergo copolymerization. We'll see it. This is CH2, C double bond OH. Here we have OH. It is glycolic acid. It will be N times. Plus we have lactic acid. Lactic acid is a similar structure. CH, C double bond OH. We have OH. Instead of H, now we will have methyl. This is lactic acid. It is a condensation polymer, minus twice and minus water. You will have OHH. You will have H. You will have OH. What you will have? You will have O, CH2, C double bond O. It is ester, polyester. It is a kind of polyester because there is an ester linkage. This is this polymer. Here it is the ester linkage. This is the polymer. Polyglycolic acid, polylactic acid. It is biodegradable synthetic polymer. Remember this point. Now we have the third biodegradable synthetic polymer. Third one, we have nylon 2, nylon 6 polymer. Nylon 2, nylon 6 polymer. It means that it will be polyamide, because nylons are polyamides, but the only difference is that here one will contain 2 carbon atoms, other contains 6 carbon atoms. Nylon 2, nylon 6 polymer. Nylon 2, it is glycine. This is glycine. Simplest amino acid. Simplest amino acid, that is glycine. You have to discuss it in the proteins, glycine. And we have nylon 6, E-amino caproic acid. We have this one, C double bond OH. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and you will have NH. We have already discussed it in the nylon 6, E-amino caproic acid. We have discussed it, E-amino caproic acid. E-amino caproic acid. Nylon 6 में हमने पढ़ा है caprolactam upon hydrolysis yields E-amino caproic acid. It will be also N-times. यहाँ पे OH है because it is carboxylic group. Water will come out. H from this will come out. OH will come from this amount, from this. It means that it is also a condensation polymer. Condensation polymer. And what we will have now, you will have NH, this one, you will have CH2, you will have C double bond ONH, polyamide hai, C double bond ONH, then you will have CH2 how many times? 5 times, 1, 2, 3, 4, 5, then at the end you will have C double bond O. It is nylon 2, nylon 6 copolymer. Nylon 2, nylon 6 copolymer. It is also biodegradable synthetic polymers. These biodegradable synthetic polymers, they degrade in the week's time, within days, within hours, and hence they do not cause any kind of pollution problem in the environment. Remember this point. Hence nowadays we try to synthesize polymers, synthetic polymers, but they should be biodegradable in nature. This was the last topic, important topic of polymers, but here I will mention another important topic. Remember this point, that is stereochemistry. Stereochemistry of polymers. Stereochemistry of polymers. Here I will consider polypropylene. Polypropylene. Stereochemistry, arrangement of atoms or groups in the space, that is stereochemistry. Remember this point. We will discuss it by taking the example of propylene. Remember this point. Under different reaction conditions, temperature, pressure, use of catalyst, propylene is a polymer. We will discuss it. It takes 3 stereoisomeric forms. You can first mention under different reaction conditions, under different reaction conditions, under different reaction conditions like temperature, pressure. Remember this point, use of catalyst, propylene takes following 3 stereoisomeric forms, following three stereoisomeric forms, following 3 stereoisomeric forms. It takes following 3 stereoisomeric forms. We'll discuss these 3 forms. But first I will consider the propylene, polypropylene, what sort of polymer it is. And then you can understand this topic. Propylene is this one, CH2 double bond CH. This is propene. Here you can say propylene. Common name is propylene. If it is N times, what will happen? CH2 valence will be created. You know the mechanism. Valencies will be created. It will be enzymes. It is polypropylene. Polypropylene. Now we will mention a polymeric chain of polypropylene. How you can represent it? You will have CH2. First you have to mention this, then you have to mention this polymeric chain, CH2CH, CH3. This is the repeating structural unit. CH2, CH, CH3. This one. You have another repeating structural unit, CH2, CH, CH3. This one. This is the polymeric chain. First you have to mention this, then you have to mention this. This is the repeating structural unit, CH2, CH, CH3, CH2, CH, CH3, CH2, CH, CH3. We will draw it in a zigzag manner. We will understand it in a better way. You will have this one, CH2, then you have CH. We will draw its bond line notations. Bond line notation, we don't represent the carbon, hydrogen, this basic sculpture. This is CH2, this one. You will have CH. Here on the CH we have CH3 and H. On this carbon we have CH3 and we have H. Let us say we have H. This one. Yeah, first we draw it, then we discuss the forms. On this carbon, this is the CH2. This is CH2. Then we have CH. On this C we have methyl and H. This is. Then we have again CH2. This is CH2. Then we have again C. On this we have CH3. We have H. Again we have CH2. This one. Then we have C. We have CH3. You have H. You can have another CH2. Then we have again C. On this we have CH3 and we have H. And so on. And so on. This is the polypropylene. This is polypropylene. You can draw it in the zigzag manner, in a bond line notation. Now we have three forms. We have three stereoisomeric forms. The first form is isotactic. 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 Iso means same. Same pattern. Same pattern. It means that arrangement will be same. The positions of methyl groups on this zigzag bone will be same. On the zigzag form will be same. I will draw this isotactic form. We have CH2. Then you have C. On we have methyl. I will draw above the plane. Hydrogen below the plane. This way. Then you have methyl, CH2, methylene. Then we have again C. If the methyl groups and hydrogen atoms occupy the same positions on this zigzag backbone, methyl above the plane, here also the methyl above the plane. This is the stereochemistry. How these are arranged, how methyl and hydrogen, these are arranged. This is stereochemistry. We have again methylene. We have C, methyl group above the plane and hydrogen below the plane. This is the way. You can draw one more. You have methyl group above the plane and hydrogen below the plane. It means that in this form, in this stereoisomeric form, in this arrangement, the methyl groups occupy the same positions on this zigzag backbone on this arrangement. This is isotactic. How you can define the isotactic? In this form, stereoisomeric form, in this form, methyl groups occupy same positions. Occupy same positions on the zigzag zigzag backbone. Zigzag backbone means on this very element. Methyl groups occupy the same position. It is isotactic. Now we have another that is syndiotactic. We have the second one that is syndiotactic. Syndio meaning alternate position. Syndiotactic. Tactic. Syndiotactic form. Syndiotactic, it is a Greek word meaning alternating. Alternating. You have alternating form. What will happen in this very form? The methyl groups will occupy alternate positions. You can first say in this form, methyl groups will occupy alternate form, alternate forms, alternate positions. Alternate position. Syndiotactic. The arrangement will be same. Only difference will be in this on this carbon methyl group on the above the plane, but on this carbon it will be on the. I will draw it again. You have CH2, C, CH2, C, CH2, C has. Here methyl group is above the plane. Hydrogen is below the plane. Here hydrogen will be above the plane, methyl group will be below the plane. This will be the case. Here again methyl group will be above the plane, hydrogen will be below the plane. It will be repeated. Hydrogen will be above the plane and methyl group will be below the plane. Alternate. This alternate stereoisomeric form is known as syndiotactic form. And the methyl groups, they are present alternatively on the zigzag backbone. Now we have the third one, atactic. Atactic form. Atactic form means no form. It means that methyl hydrogen, they are randomly oriented. They are randomly present. In this form, you can mention it in this form. In this form, methyl groups are present randomly. We will draw it. What is meant by randomly? Atactic. This one is atactic. This one, if methyl group on the first carbon is above the plane, hydrogen below the plane. Methyl group present above the plane, hydrogen below the plane. Now, hydrogen above the plane, methyl group below the plane. Now again, methyl group above the plane, hydrogen below the plane. There is no form. They are randomly oriented. When the methyl groups and hydrogen, they are randomly oriented. This stereoisomeric form is known as atactic form. Remember this point. This was about the three stereoisomeric forms of the polypropylene, which the polypropylene adopts under different reaction conditions of temperature, pressure, and you can make use of the catalyst to take any one of the stereoisomeric forms. Remember this point. Now, I will tell you the last point in this, which we have missed during the mechanism of polymerization. Question may come, give the preparation. Give the preparation. Give the preparation properties. We have missed this while discussing the addition polymers. This is the polymer you have to mention. You have to keep it in mind. Preparation properties and uses of polymethyl methacrylate, Pmma. What is the abbreviation? methyl polymethyl methacrylate. I will give the preparation of Pmma, polymethyl methacrylate. It is an addition polymer. It is an addition homopolymer. Addition homopolymer. Remember this point. Addition homopolymer. Then you can consider the text to mention the properties and uses of Pmma. I will tell you the preparation of Pmma, polymethyl methacrylate. Dear student, this is polymethyl methacrylate. First, you should know what is methyl acrylate. This is methyl acrylate. CH2 double bond C. You will have CH3. You will have C double bond O, OCH3. This one is known as methyl acrylate. Methyl acrylate. Methyl acrylate. It is actually this one. Methyl acrylate. When it undergoes polymerization, it forms Pmma, polymethyl methacrylate. We will consider its polymerization now. CH2 n times, double bond C, CH3. I will mention this part here, C double bond O, CH3. This one. It means that during polymerization, pi bond will break. This will form bond. This will form bond. What will happen? You will have CH2. It will form bond. Single bond C, it will form bond. Here we will have CH3, we will have C double bond O, you will have CH3. This is known as Pmma, polymethyl methacrylate. It is an addition copolymer. You should know the monomeric unit of this one. It is methyl acrylate. When it undergoes polymerization, addition polymerization, homopolymerization, it forms polymethyl methacrylate. You can mention the properties of this. It's a light trans. It can be used and alternate to the glass. Instead of glass, we can make use because light can pass through this. You can mention the properties and you can also mention the uses of Pmma, polymethyl methacrylate. We have to mention this. We have discussed polythene, we have discussed polypropylene, we have discussed polyvinyl chloride, we have discussed polyacrylonitrile, we have discussed the polystyrene. Large number of, we have discussed Teflon. In the same way, we have another addition polymer, that is polymethyl methacrylate. With this, we have completed the polymer chemistry. And inshallah, in the next lecture, we will start with another important unit from the physical parts, that is surface chemistry. Inshallah, now we'll start the polymer chemistry in the next surface chemistry in the next lecture. Till then, fi amanillah.